This is a laser engraver we built using a cheap Amazon CNC and 20-watt optical powered diode laser from AliExpress. We use it to engrave stainless steel, and this little machine works 4 to 6 hours a day just to keep up. Let me show you how we modified this unit for laser use and what to expect from a 20-watt laser. We typically use CNCs worth tens of thousands of dollars, so let's take a look at how the cheapest machine I could find compares. So here's the machine we bought. It is the 1610 Pro milling machine. It is a 3-axis machine, GRBL controlled, 18 by 10 by 4.5 centimeter working platform. I'm sure you've seen these around. I think they are the least expensive machines you can buy on Amazon. This is the small version. They also have slightly larger versions. It is a whopping $175, and that is the premium version that comes with the little offline controller, which is just down here. That's the one we bought. I just wanted to have the controller in case. I've never used it, but it's there if I need it. The whole machine is built off these aluminum extrusions on the side and the back here, and then the front, rear, and side panels, they're all some sort of high density plastic. The rail systems are just 15 mil round rods. The whole Z-axis here appears to be 3D printed plastic maybe. It's just some sort of low grade plastic. And then the table is just a standard T-slot aluminum extrusion table. The screws, the lead screws for the drives are all an Acme style feeding into brass nuts with spring tensioners, just take the backlash out of them. The motors driving everything are NEMA 17s, and they are wired back to the controller. It's all plug and play. There's no soldering or anything that has to go on like that. The kit comes with some little engraving bits, a flash drive for the software, and the power supply. So everything's included, including the spindle, this 120 watt spindle. I imagine that would be pretty useless. We didn't need it anyway, so just set it aside for something in the future maybe. But other than that, this machine is exactly as pictured. We had one fault with one of the rails. They were a little bent when they showed up. Was not going to affect the machine for our purposes, so we didn't really care. And again, I wasn't expecting much for the price tag, so I'm just glad that I got all the parts. The entire machine has to be put together. It comes entirely in pieces, but the assembly was pretty straightforward. You could pretty much do it just by looking at the pictures, so no complaints there. And everything was included, which was the main thing I was concerned about. Once we had the machine purchased and assembled, we just needed our laser head. So this is the laser system we bought. It's a 20 watt optical power laser, 80 watts advertised. This is a slightly updated design. They must have changed them since. I noticed you can also buy a 30 watt optical power laser now, which you couldn't when I had bought the 20 watt one. It was the most powerful diode laser you could buy. They've since changed that, so I suspect at the same time they updated the design. It's effectively the same. Ours has the air assist nozzle for the laser, the little controller, external power supply, the shims, and the wiring as well. We did pay about $610 shipped for everything that was included. The listing does state that it is capable of engraving on stainless steel. I was a little bit skeptical when I was buying it. That's why we bought the most powerful one we could, just because that's exactly what I needed it to do. Pretty decent little unit. It was put together pretty well. It uses a 4 diode system. The newer 30 watt ones seem to use a 6 diode system. Everything was plug and play, and that includes from the laser controller here down to the GRBL controller, just a standard little 3-pin connection. I believe I had to switch one of the pins on the little connector because the polarity wasn't correct, or the PWM signal in the ground might have been mixed up. But other than that, it was basically plug and play. To mount the laser, we had to cut the spindle mount part off the Z-axis with a bandsaw. Then we made this simple aluminum bracket to hold the laser head in place. The center offset of the laser is slightly larger than that of the spindle it replaced, so we'll lose a little working area on the table, but for us it won't be a problem. With the laser installed, we mounted the laser controller on top of the GRBL controller on the back here and ran all the wires. This was pretty much plug and play, with the laser controller receiving a PWM signal from the CNC controller. So here's what the wiring looks like. Over here we have our laser head and the little controller that runs it. This one looks a little bit different, but this was the only image they have. The pinning out is the same. Over here we have the GRBL controller for the CNC. So this was the diagram provided by the manufacturer, which shows how all the connections are made back to the little GRBL controller. As you can see, it's kind of got room for everything. It's not too bad. I've blown up this section here. This is where the PWM signal goes back to a laser head. So down here we have our pinout on the GRBL controller, and that's 12 volt PWM and ground. And as you can see, that's different from the PWM ground 12 volt signals as they're currently set up here. So it's hard to tell from this mixed orientation, but the 12 volt power supply is actually in the correct place as far as the harness is concerned. And then you just have to switch your ground and PWM pins, and everything will line up as it should. The PWM signal will allow the control software to throttle the laser power required for any specific operation. Both the GRBL controller and laser controller need their own power supplied, as the GRBL controller cannot supply the 80 watts of power to run the laser equipment. For some smaller lasers, this unit can be switched from external power to receive electricity directly from the GRBL controller. This unit is set up to accept an air supply, which we are not using. The air supply should improve the cut quality. Because we were engraving, we thought we wouldn't need it. However, I do believe it would protect the lens from contamination of dust particulates, of which we do have quite a few. There's a lot of little particles that come off the engraving process, so we'll eventually upgrade. The pump is about $150, and it's just a little low pressure sort of semi-volume pump. They are available through the same listing that the laser was. We've installed this jig onto the surface of the machine. It only serves one purpose for us, and that's to engrave some stainless steel tags. All the tags are the same, so the walnut jig holds the blanks in a consistent location that is templated back into Lightburn, which is what we use to run the machine. With this setup, we can produce the tags up to 6 at a time without ever having to zero the machine.
These are the tags that we are engraving. They are a 14 gauge stainless steel tag in a number 4 finish. Due to the thickness of the tags, I was worried about heat dissipation affecting the laser's ability to engrave the surface, and because the listings for products like this are often unclear on specifics, building the machine was a bit of a gamble. It took some playing around, but we were able to achieve the result we were looking for with a 40,000 spacing at just 80% laser power. With these settings, our parts have an approximately 5 thousandths of an inch burn depth with good resolution. The standard linear CNC process it uses at a 40,000 step over means a considerable amount of movement is required to achieve the result. Compared to a fiber laser system at 3 to 5 times the cost, this machine is definitely considerably slower and less efficient at producing the engravings. So it may not work for everybody depending on your specific needs, but for us it's not a problem. That's the reason this little machine sees so many hours of use. A typical working day will require it to produce 12 to 18 tags at a little over 2 hours per set, or 4 to 6 hours per working day. Considering that, I'm very pleased with this machine overall. Neither the laser nor the machine itself have given me any trouble since I built it.
Given that, I think the 3.6 star review for this machine is a little unfair, just given the price point. It's worked great for us, and I would certainly recommend it for certain applications. The overall build worked really well. It's got a smaller footprint than some of the other machines that are available, and it serves the very specific purpose in which we built it for quite well. Likewise for the laser head, I'm quite impressed with the Diode laser systems. This 20 watt system seems to have quite a bit of power. Like I said, we don't even need to run it at full capacity. And the newer 30 watt models, I imagine, are quite capable little systems. I would certainly be interested to try one, and maybe one day I will find an excuse to buy one.